Today we are specifically looking at absolute value inequalities. So the absolute value is either going to be less than a number or greater than a number. Whichever way it is going to determine how we set up this inequality to solve. And I'm going to try to teach you some tricks. So if the distance from 0 needs to be smaller than 2, I want the value of x to be less than 2 units away from 0. So -1 is less than 2 units from 0. 1.5 is less than 2 units from 0. Anything in this range in between the -2 and the +2 is going to be less than 2 units from 0. So this is an and inequality. -2 is less than x is less than 2. So we take this 2 and we look at -2 and +2 are like the boundaries, and we want everything in between that. So it's an and inequality. If we want the distance to be greater than 2 units away from 0, then 3 is more than 2 units away from 0. -3 is more than 2 units away from 0. We still have -2 and 2 as the boundary, but we want the stuff that's farther away from 0 than those numbers. This creates an or inequality. Our x values can be smaller than -2, or they can be larger than +2. So greater than inequalities with absolute value give us an or inequality. So here's kind of a summary of that. If it's less than, I'm going to say less and than. If it's a less than inequality, it's going to be an and inequality, where we do negative number less than stuff less than positive number. If it's greater, I'm going to think great or. So it's an or inequality. You still look at positive C and negative C, but it's going to be greater than positive C or less than negative C. Okay, let's try this out. Absolute value of stuff is less than 11. Less and great or. So you may want to write less and great or. When it's an and inequality, we are going to use negative number, same symbol, stuff, same symbol, 11. So -11 is less than 2x plus 7 is less than 11. Now let's solve this and inequality. We solve this and inequality by subtracting 7 on both sides, or all 3 sides. So we have -18 is less than 2x is less than, why is this hard in my head? 11, 10, 9, 8, 7. That's 4. Then we divide all 3 sides by 2. To get -9 is less than x is less than 2. If we need to graph this, put -9 on the graph, put +2 on the graph, open circles, and shade in between. Number 2 is another less and than. So less and, we need to set up a 3-part inequality. -21 less than or equal to stuff, 4x minus 9, less than or equal to +21. Notice I used less than or equal to because that's the symbol that was given to us. In number 1, it was just a less than symbol, so we used a less than symbol. In number 2, it's a less than or equal to, so we use a less than or equal to. I want you to pause the video and finish solving this 3-part inequality on your own and try to graph it while you're at it. I got -3 is less than or equal to x is less than or equal to 7.5, and it's fine to use a decimal there. So when we graph this, we've got -3, we got 7.5 up here, this time closed circles because it's less than or equal to, and we shade in the middle. Any number in between -3 and 7.5, including -3 and 7.5, when you plug it into this equation, it will create a number that is smaller than 21 units away from 0. Next, let's look at some greater. Remember, great or. So greater than absolute value inequalities, we set up one that's exactly the same but without the absolute value bars. So 3x minus 2 is greater than or equal to 8. The other one, we flip the inequality symbol and we take the opposite of the right side. So when you switch to the negative, that's when you flip the symbol. If you aren't switching to the negative, you don't flip the symbol. This is an OR inequality, which means, yes, we do have to solve both of these. So pause the video, solve both of these inequalities, and then we'll look at graphing them. Now, some teachers would say, you need to rewrite these with this answer on the left and this answer on the right. I don't necessarily need you to do that. I just need you to remember that -2 is over here on the left, 3.33 would be on the right. They would both have closed circles. In this inequality, x is less than or equal to -2, so closed circle, we are going to shade to the left. In our greater than inequality, closed circle at 3.33, and we are going to shade to the right. I would like you to try number 4 completely on your own. Set up the inequalities, solve it, graph it. If you're struggling to get started, let me help you. One of the inequalities is exactly the same. Change nothing except just don't write the inequality symbol. The other inequality, write the stuff down, less than the opposite. So you're switching the inequality symbol and you're flipping it to -5. Now solve both of them. Pause the video, solve both of them. Oh, hey, remember this? If we have to divide by a negative, what happens? We have to flip that symbol. So x is less than 5/3, which is like 1.67. And then here, when we divide by a negative, x is greater than 5. So this time, it actually works perfectly on our graph. Open circles this time. The less than inequality is here. That we shade to the left. The greater than inequality, open circle at 5, shade to the right. Okay, there's a couple more compound inequalities. I really want to touch base on number 6, but take a look at number 5 quickly. What do you think we would do in number 5? We would start by subtracting 6 on both sides. So we'd have absolute value of stuff is greater than 6. This would be a great or like we just did. Let's look at number 6. When we add 8 to both sides, we get absolute value of stuff is less than or equal to -1. Less than would be less and, but oh, hold on. There's a negative on the right side when we have inequality or we have absolute value on the left side. That's a potential problem. So I want you to think about absolute value on the left side is going to result in a positive number. On the right side, we have a negative number. So think about what that means. Can a positive number be smaller than a negative number? That's not possible, so there would be no solutions. It is not possible for a positive number on the left to be smaller than a negative number on the right. Okay, sorry about the text that's up there. All right, let's look at this next one. We would first add 7 to both sides. So we'd have 3 times the absolute value of x plus 1 is less than 6. And then we would divide both sides by 3. So absolute value of x plus 1 is less than 2. That is a less and. So you would set it up -2, less than x plus 1, less than 2, solve, and graph. Okay, let's look at number 8. I'm assuming that you could finish number 7 on your own if you needed to. Number 8, I would start by subtracting 8 on both sides. Sorry if there's any extra noise in the background. Then I would divide by 2. Okay, once again, we have absolute value or something and then a negative number. So I want you to think about what this is. Absolute value is going to give you a positive. -4 is a negative. Is a positive number going to be larger than a negative number? Yes, always. So your answer would be all real numbers or many solutions, or however you want to write that. Work together with your neighbors. Work through the assignment. If you need help, ask your classmates for help. You can also email me for help if you need it. Hopefully you're doing all right, and I will see you tomorrow. By the way, if you made it all the way through the video, I'm going to ask you when I come back what my favorite number is, because that's what I'm putting in at the end of the video. My favorite number is 1024. That happens to be the number that is 2 to the 10th, and it is my favorite number, 1024. And I can tell you more about that later, but I'm going to ask just to see how many of you got to the end of the video.